studiul nostru este bazat pe 3 piloni importanți. Unul, studiul de călătorii pe care îl face BRAT, împreună cu 3 parteneri locali, bazându-ne pe studiul de mobilitate pe care îl facem împreună cu cele 3 companii locale și pe un inventar al panourilor realizat intern de BRAT. Toate datele astea pleacă la companie Cuende, care o să explice mai pe larg ceea ce fac ei în zona de modelare a călătoriilor și de vizibilitate, pentru ca la final tot Cuende să pună împreună toate datele astea pe o hartă digitală și să rezulte datele de audiență pe care le vedeți. Studiul de mobilitate este făcut în 11 orașe, are un eșantion de aproape 16.000 de oameni, făcut după cele mai înalte standarde și nu exagerăm, de extragerea eșantionului, de contact al persoanei, de colectarea datelor, atingând o rată de răspuns de 60%. 60% înseamnă, din 100 de oameni la care am bătut la ușă, 60 ne-au răspuns, adică am primit răspunsul de la ei, poate nu răspunde prima dată. Asta cumva dă seriozitatea și atenția pe care o punem în rezultatele astea și cumva și toate rezultatele pe care o să le vedeți sau le-ați văzut se bazează pe ele. Studiul de mobilitate pune întrebări de mobilitate. Cum circulă oamenii, de unde până unde, cu ce mijloace de transport, la ce oră, în ce scop, de câte ori și așa mai departe. Sunt date care se duc apoi la Cuende pentru a face toată modelarea. Așa arată studiul nostru, care este făcut CAPI, adică cu computerul, și unde respondenții sunt ghidați cu ajutorul întrebărilor și răspunsul lor este transmis online în momentul oferirii lui într-o bază de date. Pe lângă faptul că voi ne dați, companiile de OH, datele, cineva se duce și măsoară real, în teren, că ce ne-ați dat voi este corect.
So, getting focus on methodology, in the next 5 hours, I'm going to explain the methodology. Okay? Not? Okay. It's quite simple. Basically, we have 2 main concepts. How the people move in the city and where are the panels, where is the inventory. As simple as that. How the people move is how we get those travel patterns. The SMR global guidelines say very clear that there is no way that you can do it with only one source. You have to combine traffic modeling, traffic counts, interviews. You have to do a combination of survey data. So that's a hybrid approach. And in fact, it's all the research, we are moving to that area. Hybrid because we need right now that kind of big data that really helps to do a measurement across all areas, all regions. When we talk about big data, okay, how we can get big data for Bacau? How we get that? So the trick here is to use high resolution satellites. We use we have a partnership with Digital Globe Maxar. This is a big company, well, in fact, it's the biggest company of high-resolution images that works for the Department of Defense of US. And in fact, sadly, you have seen lately a lot of images of Maxar because the war, all those satellites of Kiev, it's Maxar who are taking those 30 centimeters resolution. They are able to count everything and see everything. So we have partnership with Maxar. In fact, they are really involved. From here, I will fly to Lisbon just to do the conference with agencies, European agencies with Maxar. And these guys have an absolute control and images across all the world and, of course, about Romania. So the idea is we have to transform this big data, terabytes of data, 100 petabytes of data, we have to convert it on metrics. How we do that? Okay, we are able to detect and to count cars. So an image is about 2,000 square miles, and we are able to detect every single car. And so not only the cars in one street, but compared intensity from one street to another. So, but when we take that image, it's not only from one street, we have the complete region, the complete area. So it's like a snapshot of the whole city in one single image. That allows us, not with only one, but with many of them, across days, across hours, across months, to have a really accurate intensity traffic for every street. This will allow later to do the proper travels, the proper counting, the proper weighting of any travel across the streets of the city. Thanks to the survey, we have the origins and we have the destinations. But the idea is that we don't know for sure how was the possible track or the path that someone took from point A to point B. What we do is we do the probabilization or something similar based on the traffic intensity, because we know how many cars are here, there, or the other one. So we are able to balance what is the most probable path. So for one source, thanks to the survey, we have time, origin, destination, duration. And thanks to the satellite, we know we know what is the most probable path for every single route. When we combine, we have a very good representation of reality, both origin, destination, reasons, and also the volume and the traffic of every single street. All this combined with more information, media consumption, everything that Arina has already told you, we combine all this and we have what we call an atlas. Every single individual of the survey, we have a deep knowledge of how he moves, why he moves, what he buys or what he sees, what is media consumption, and we have all the journeys and reasons that he is moving across that region and that city. We haven't talked about billboards yet. If you see, all our effort is being to understand perfectly how the person or any individual moves in one city. Once we have that, let's move to the other part. Let's talk about inventory. Let's talk about panels. All those panels, as you have seen, are identified, located, and placed with a software thanks to BRAT. They are centralized, all those elements. With on a digital maps and even points of interest, as you have already seen. That's it, right? We know how the people move. We know the inventory. That's it. As easy as that. Well, it's not exactly. I wish it could be as simple as that, but not all the cars that are moving here or the people that are on that bus shelter are going to look at that panel. Traffic is not audience. This have to be very clear. We have to analyze the visibility zone. We have to take into account the visual sharpness, how far someone can read, what is the location, what is the orientation, what is the size, what is the haze, what are the obstacles. Many things have to be taken into account to really guarantee that someone has the opportunity to really see that billboard. It's not about traffic, that's easy. So how we calculate that visibility zone? We analyze the visual sharpness of this alpha angle. Is everybody have the same visual sharpness? If you don't have the same, you will use glasses. So we see normally the same. At that distance, we can see, we can read, okay, because everybody can see very far away. But we need to read. We need to read what is the text of that billboard. And what we are going to do is, for example, how is the shape? Imagine that we have in this boulevard a panel, and we have we put here what is the real visibility zone. That's alpha. That's our visual sharpness. Everybody who is inside that billboard will read perfectly. What is the advertising? What is the advertising? What is the text? But our question is, but maybe it's not only that. Maybe someone in other place or in another location is able to read it. How we calculate that? We make a very simple geometric analysis. Imagine that the triangle is a solid thing, and we put here two solid elements, and we are going to move this triangle and keep the same size of the billboard. So keeping alpha, keeping the same visual sharpness, what we discover is that most of you already know it's a circle. It's a very, very simple approach, but it's reality. That's the definition of a circle. So everybody in that area will read perfectly the billboard. That's enough? Well, that information, in fact, is not only us, it's shared among associations and US SANGL, the European Commission of Science. So, but the other question was if this was enough. Well, no. There is a kind of blind area, there is a shadow. If there's in the top of the building or in a column and it's too tall, someone who is very near will not be able to see that billboard. So we have to take into account the maximum eye rotation. So it's another factor. And in fact, this is a real example. You can see the billboard. I don't know if this. There, where is the panel? This kind of shadow. What is based on the height of the blind area, and what are the segments of the street that really are, someone can really see that billboard. And this is important because the time of exposure will be later used for the visibility analysis on digital panels. It's not the same that you are only staying 10 seconds or you are staying 30 seconds or 90 seconds on the visibility zone. So the speed and time in exposure area will be used. And those factors are called VACs, visibility adjusted factors, that take into account this kind of information. Because it's not the same that someone is walking or someone is driving to see that billboard. The factors will be taken into account. It will change. It's not the same that we are driving in one lane or we are driving at 120 kilometers per hour in 7 lanes. It's not the same that you are going in one direction, that you are going in the opposite direction, driving for a horizontal panel. It's not the same if it's on the roof or if it's in near at the basement level. And light is not the same if it's not illuminated or it's backlight illuminated by night. Talking about light, it's not the same Bucharest in July. There's 15 hours of light that in December, there are only 9 hours of light. So the possibility to see the billboard, the audience of a billboard in July, a non-illuminated billboard in July and in December will be different. And of course, very obvious, but you have to take that into account. This is not a contact. He's in the visibility zone, at the proper distance, on the correct position, but not on the valid orientation. He is not facing the billboard, that's not a contact. This is a contact, and good impact, in fact. What about digital? What about dynamic panels? Dynamic, in fact, comes from root. They define not only digital, but everything that moves. So we call them dynamic panels. What we do that is we use a methodology that was generated from the World Organization, FEPE at that time, that now is called World Out of Home Organization. And with GCDeco, Clear Channel, and many other players did an eye tracking analysis to see what is the impact of digital and how should be the VACs, the visibility adjusted contact for digital. Till now, what I told you is we have how the people move, what is the inventory, and we do this kind of visibility analysis. We take all this, but now we increase with new factors, new elements. The first one is the dynamic factor, because they are changing, and the other one is what we call attraction, digital attraction, because it's not the same a static paper than a full motion. Let's go for the first one, the dynamic factor. Remember that I told you that digital, the speed and the time was relevant? So now we have to take into account these two concepts, the spot length, 10 seconds, 20 seconds, and the other one is the loop length, how long is going to be repeated that same spot. And here is a clear representation, how we have the spot time, second by second, what is the time of exposure, so you can see that the chances may be very different. It's a 10 seconds, 40 seconds of spot length in a 60 seconds loop, but you may be 1 second, 2 seconds, 9 seconds, 2 minutes, all those factors. How we can calculate that? Well, this is the formula. And this is a standard formula that we are applying across the world. This is provided by these measurements, standard measurements. The first one is to use the time of exposure, how long, how many seconds he's going to be in the area, what is the spot length, and between the total loop length. With that, we have a factor that will decrease the total time of exposure. And the other factor is attraction, digital attraction. We use the same study, and what it says that a static paper has what is the uplift, the attraction, if someone sees a paper versus someone watching a full motion. In fact, you have been already tested. When I put this, everybody has looked at this, right? That's the attraction factor of the digital, and we have to use it. We have to take that and put it in information that everybody who's passing through this billboard, the chances to, if there is these 4 elements, the chances to see this one is going to be greater than the chances to see a static paper. So, and in fact, these are the variables, and this is the correction factors that they are using. If it's head-on, if it's parallel, if it's inside, if it's driving, if it's pedestrian, all those factors are included in the system. So now we have added these new factors, and how we combine? Well, we have the paper impacts, the static, as it was a normal panel, but now we have these digital factors that will correct some of the factors. The dynamic factor will, based on time, exposure, spot length, will decrease the probability, but the digital VACs, based on that attraction factor, will increase. All those numbers will finally get the digital impact. How many people will see that billboard? So this is a real example, but just to understand, if there is one person driving, is a driver, it has parallel, so imagine that the contacts are 100, the time on the area is 11 seconds, the spot time is 30 seconds, the loop time is 80, so that will be the dynamic factor, the calculation that I show you the formula. That will be the digital attraction, so the uplift is almost 2, so the final factor will be 0.95. So when we had 100 impacts for one person, for one individual, this will become 95. We can do this for different individuals or even the same individual passing by different times, and we will see that it's going to change based from what is the source and what is the final result. So if we had originally 800 impacts, the digital ones, because they have that spot, because they are basically 30 seconds of 80, they will become 531. So in this case, it's less. Okay, what's the results that we already seen a part of them? The first thing to understand the results is what we call the exposure. So this is a digital that has 10 seconds of a spot, and it's repeated every 360 seconds. That will be that only 3% is exposed. There are other more regular, for example, one that is going to be default is 15 seconds in 90 seconds, or 10 seconds in 60 seconds. So this ratio of exposure is really relevant to understand what is the part of the spot of the total repetition. We have agreed to use as default values between 10 and 15 and 60 and 90 seconds from spot length to loop length. And in scroll, it's 1040. To get an idea, just an idea, a ratio of 70%, that means the standard 10 seconds of a spot that repeats every 60 seconds, paper versus digital will get 20%, 21% less impacts and 20% less reach. But as you can see, it's only 1 of 6. That you have another 5 spots more. So it's not bad. Let's see what really happens and how is the ratio. We want to transmit you what is the ratio, what is really the relevance of this spot and time duration, that you can have it here, and how we impact really on impacts and reach. So if there is a 50% ratio, you lose only 4% of impacts and 4% reach. So it makes sense. Almost everybody who goes through a digital, almost everybody will see it. If you are changing, and for example, you go to the standard one, 10 seconds of a spot in 60 seconds loop, you will lose, and this is a real data that we have with 100 panels, you will lose about 30% impacts and 24% reach. If you go to some extreme, we don't recommend that at all because we are losing really the value of digital. If we go beyond this, the impact is really high. Beyond this 80% or near below this 8%, we are near 50% losing those impacts. So one of the recommendations, and we will talk later, is you have to keep digital, how I say it, a little bit premium, a little bit on the top. Don't recycle, don't keep those areas enough to visualize. I want to really visualize the digital spot on the loop. Okay, the question is, okay, if I am with this division, how will the difference between the increase in the seconds? How many seconds will I increase? This is an example. So imagine that we have a panel, a base impacts of more than 200,000. And this is 10 seconds. If we convert it to digital, this is 10 seconds of 60. We have 193, almost 90%. That's a very good approach. If we have 20, it's 200. You have 30, 99%. And below 40, we almost get everything. So really ask for that kind of duration on because you are getting really the same part of the total audience. As we increase the number of seconds, we get almost as paper. But at the same time, I am a media owner, and do I lose value with dividing? Because why we are doing this research? Because someone said, oh, if it's one spot among 6, I'm going to divide the audience in 6. No, that's a really mistake. You can see that the base impacts, digital impacts will be 193, but if you divide by 6, you only have 35. So that's not a good hypothesis. Never divide impacts by the number of spots. Use the research. And in fact, if we have 6 advertisers or 6 spots, you can see that the value of that panel, the value of that location is really good. Each one of them are a little smaller, but all them combined for a media owner is really worth it. If it's really worth it, if it keeps a proper ratio, because if it goes down, this number will really go down, so it won't accumulate enough. So the last thing I would like to transmit is that the research is part of the media itself. When you buy a car, how do you say, the odometer, or the number that says the kilometers, that's part of the car. It's telling you the speed of your car. So the research is part of your billboards, bush shelters. You have to put it on your DNA. It's not a strange thing that is outside. No. The numbers, the GRPs, the affinity, the TRPs, the targets, all those should become really part on your sales process, on your DNA, on your proposals, everything. It's not the only thing, but you will never buy a car without that indicator of kilometers, right? So you need that. You need to use that, because with that we really are driving. It's a driving force to the out-of-home success.